Hello everyone, let's try this problem. It says Sheena can row a boat at 2.50 miles per hour in still water. She needs to cross a river that is 1.20 miles wide with a current flowing at 1.80 miles per hour. Not having her calculator ready, she guesses that to go straight across, she should head upstream at an angle of 25 degrees from the direction straight across the river. What is her speed with respect to the starting point at the bank? Okay, so for this problem, let's see. Suppose we have this is the river straight down like this. The water is flowing in this direction with the velocity VW, and which is the current is flowing. This is VW. So our velocity of the water is equals to 1.80 miles per hour, and it says that Sheena row a boat at 2.5 miles per hour in still water. She needs to cross a river which is 1.20 miles wide. So this is the velocity direction Vs equals to 2.5 miles per hour for Sheena, and this is at an angle of 25 degree. So we can find the components of this and this. This is going to be V of Sx, the x component of Sheena velocity, and V of Sy, the y component of Sheena's velocity. And then we need to find the speed with respect to the starting point at the bank. So we need to find the velocity V of B, the velocity at the bank. What will this be? So we have VW, we have V of S, the Sheena's velocity, and that is 2.50 miles per hour. We have these two things given to us. So for this, basically, if we want to find the V of B vector, the velocity at the bank, magnitude of this, we need to find all the components of VB. So like x component of VB, square of this, plus V of B and y of this. So if we firstly see what are the x components here, so the x component, we have this V of Sx. So let's write it this way. V of Bx is going to be V of Sx with the cos of theta, which is 25 degree. So this is going to be 2.5. So this V of Sx is over 2.5 with cos of 25. So 2.5 with the cos of 25. So this whole will come out to be 2.27 miles per hour, and then V of B of y. This will be, we have two y components here. One is this V of W. So this V of W is equals to 1.80 miles per hour, and it's going in the negative x direction, negative y direction. And the other one is this V of Sy, which is going in the positive y direction. So the V of S of y will be equals to V of S of y, let me write it here. this will be V of S, which is 2.5 with the sine of 25 degree. So we have two y components, one is this and one is this. So let's find this. So V of Sy is going in the positive, which is your 2.5 sine of 25. This will be with the positive sign, and VW is going in negative, so it will be with the negative 1.8 miles per hour. So V of By, this V of By, when we will calculate it, it will come out to be negative 0.743 miles per hour. So now we have V of By, we have V of Bx. We can find the total magnitude of V of B vector, the velocity at the bank, and it's gonna be under root of V of Bx square of that, V of B of Y square of that. Just plug in the values. It's going to be 2.27 miles per hour square of this, negative 0.743 miles per hour square of that, and magnitude of velocity at the bank will come out to be then 2.38 miles per hour. Thank you.